In this lesson, we are going to look at how scale factors affect three-dimensional objects. Now, in three-dimensional objects, we investigate two types of measurements. We're going to be investigating how they affect surface area and volume. Now, surface area is the area of all the surfaces around or surrounding a 3D object, whereas volume is the space that it contains inside of it. What we're going to look at in this activity, and if you're my student, you may have your study guide out. It's a try it and do it yourself activity. You're going to be discovering the impact that scale factors have on surface area and volumes of three-dimensional shapes based on a rectangular prism. So here's two formulas that are going to be useful. Surface area of a rectangular prism is 2 times length times width plus length times height plus width times height, because there's six surfaces on a rectangular prism. The top and the bottom are the same, the left and the right are the same, and the front and the back are the same. So that's that formula there, whereas the volume is simply length times width times height. So here's our original shape that we're going to apply scale factors to right here. So here's the original. The measurements are 6 by 4 by 2. The surface area, if you look at the formula, is 2 times 6 times 4 plus 6 times 2 plus 4 times 2. And if you follow this thinking here, it's 88 centimeters squared. And the volume is 6 times 4 times 2, which is 48 centimeters cubed. So surface area is the squared type of unit, and volume is a cube type of unit because it's what is contained inside a three-dimensional shape. You may want to pause this video soon, because what you're going to do next, and I'm going to show the work for it, you're going to impose a scale factor of 3 onto this shape. So in other words, make it the measurements 3 times as large, and see what the impact on surface area and volume are. So if you'd like to try that on your own, you may want to pause the video. Okay, whether you've paused the video or not, here's some mathematics here. Now, if we apply a scale factor of 3 to each of the measurements, we are just multiplying all of the original measurements by 3. So instead of 6 by 4 by 2, it's going to be 18 by 12 by 6. Now the surface area of this new rectangular prism is 2 times length times width plus length times height plus width times height. So 2 times 18 times 12 plus 18 times 6 plus 12 times 6. And which becomes 2 times 216 plus 108 plus 72. So the final surface area of this particular shape is 792 centimeters squared. And the volume of this shape is 18 times 12 times 6, which is 1,296 centimeters cubed. Now what we're investigating is, what does that impact of a scale factor of 3 have on the surface area and the volume? So here's the first question. To get the surface area of the new rectangular prism, what would you multiply the surface area of the original rectangular prism by? So in other words, if I was to move here, essentially, what are you taking this 88 and multiplying it by to get 792? So 88 times what number is 792? Now if we know the way to do that, you could divide 792 by 88, and that will give you the multiplier, and that would be 9 times the surface area. So a scale factor of 3 creates a surface area that's 9 times greater. Last question in this particular part. To get the volume of the new rectangular prism, what would you multiply the volume of the original rectangular prism by? So if the original volume was 48, what are we multiplying that by to get 1296, in other words? Another way to say it. And we're just going to divide. So if we do 1296 divided by 48, you will get that it's 27 times the volume. Now you may want to make a prediction as far as what does the impact of scale factor have on surface area and volume, or what we're going to do in the activity is continue on to the next one and see if we can make some sort of hypothesis or observation. Now what we're going to do in the next one is use a scale factor of 0.5. So we're taking the original shape, which is this one here, and making all the measurements half the size. So instead of 2, 4, and 6, you'll see that it is 1, 2, and 3. So I've done that part here. 1, 2, and 3. The surface area of this particular rectangular prism is 2 times length times width, so that's 3 times 2, plus length times height, so that's 3 times 1, plus width times height, which is 2 times 1. So the surface area would be 2 times 6 plus 3 plus 2, which is 2 times 11, which is 22 centimeters squared. As far as the volume goes, quite simply, it's 3 times 2 times 1, length times width times height, and that would be 6 centimeters cubed. So the same questions are going to follow here. To get the surface area of the new rectangular prism, so to get 22, what would you multiply the surface area of the original rectangular prism? So the original was 88, so it's basically saying 88 times what number is the new surface area? Or if we divide, we can get that answer. So 22 divided by 88, it's getting smaller, so it should be a decimal number, and you will get that it's 0.25 times the surface area. So if we have a scale factor of 0.5, the surface area is 0.25 times as much. Last question, to get the volume of the new rectangular prism, what would you multiply the volume of the original rectangular prism by? So the volume of the original rectangular prism was 48, so it's essentially asking 48 times what value is equal to 6. And if we do 6 divided by 48, you will get 0.125, I believe. Yes. So 0.125 times the volume. So in conclusion, for this activity, and you may want to pause this shortly, I'll kind of explain it to you. The conclusion is this, so there's two conclusions to be made. What is the relationship between the scale factor and what you multiply the surface area of the original rectangular prism by to get the surface area of the new rectangular prism? Or in other words, what we found out is if we have a scale factor of 3, then the surface area is 9 times greater. Or if we have a scale factor of 0.5, then the surface area is 0.25 as large. So what's the relationship between 3 and 9 and 0.5 and 2.5? If we can get that relationship, then that would be useful. And what we learned in 8.4 is that the relationship between the scale factor and area is that it's squared. Now, is surface area the same as area in that sense? So in other words, this is 3 squared. So the answer to that is yes. Or in other words, this is 0.5 squared. So the relationship, if I would like to write out a formula, which may be useful, is that the original surface area times the scale factor squared is equal to the new surface area. That's the relationship. And the last and final relationship we're going to look at in this particular lesson is the relationship between scale factor and volume. So what is the relationship between the scale factor and what you multiply the volume of the original rectangular prism by to get the volume of the new rectangular prism? So in other words, if we have a scale factor of 3, we found out the volume was 27 times as great. If we had a scale factor of 0.5, the volume was 0.125 as great. So what's the relationship between 3 and 27 and the scale factor of 0.5 and 0.125? You may want to pause this and think about the relationship yourself. The more you come up with the hypothesis yourself, the more it will stick. Okay, the relationship is the following. Since volume is a cubic type of unit, you may have presupposed or just guessed that this is 3 cubed, or in other words, a scale factor cubed. And 3 times 3 times 3 is 27. So the answer there is yes. Or in other words, to test your hypothesis, is this 0.5 cubed, or the scale factor times itself 3 times? And you will find that the answer to that is also yes. So if you were to put this into a formula, here's the relationship. The relationship is that the original volume, and these are the two key ideas for this entire section, times the scale factor cubed will give you the new volume.